Welcome to Data Structures and Algorithms with Typical Monk. Class 1, How Coding Interviews Actually Work. If you have ever opened a coding interview website, seen a wall of 500, 1,000, 2,000 problems, and felt your heart sink, this class is for you. Here is the secret the best candidates know, and most beginners never hear. A coding interview is not a memory test. Nobody is checking whether you have memorized 2,000 solutions. The interview is a proxy, a controlled way for a company to watch how you think when you meet a problem you have never seen before. Do you ask good questions? Do you find a simple solution first, then a better one? Do you write clean code and test it? That is what they are really measuring. A candidate who calmly reasons their way to a decent solution will almost always beat one who blurts out a memorized answer but cannot explain it. Because the job is not reciting code, it is solving problems nobody has solved before. And beneath those thousands of problems lie only about 20 recurring patterns, a handful of core techniques that show up again and again in disguise. Learn to recognize them, and roughly 90% of interview questions suddenly look familiar. Over this course, we will build DSA from the ground up, one idea at a time. Complexity, arrays, hashing, recursion, trees, graphs, dynamic programming, and every pattern that matters, in clear, language-agnostic pseudocode, in Hindi and English together. Today, the map, how a coding interview really works, the pattern mindset, the tools you will use, and the road to becoming interview ready, one idea at a time. Here is the map of today's journey. 6 ideas that turn the terrifying world of coding interviews into something you can actually plan for. First, why interviews test DSA at all, what they are really measuring. Second, the anatomy of a round, the exact arc every coding interview follows. Third, the pattern mindset, the single insight that shrinks thousands of problems into a handful. Fourth, BIGO and the core data structures, the language of efficiency and the tools you build every solution from. Fifth, the 18-module roadmap, the path this course takes in careful order. And sixth, how to practice and truly become interview ready, one idea at a time. Let us begin with the big picture, drawn as a funnel, because it completely changes how you should feel about that intimidating pile of problems. At the very top sits the overwhelming part, 500 more practice problems, the endless list most people try to grind through one by one, growing more exhausted and discouraged with every passing week. But watch what happens as we move down the funnel. All those hundreds of problems narrow down to only about 20 core patterns. Recurring techniques like two-pointers, sliding window, and binary search that appear over and over across completely different-looking questions. And below even the pattern sits something simpler still, one underlying problem-solving framework, a calm, repeatable way of thinking that you apply to anything unfamiliar. The whole mountain rests on that single foundation. This is genuinely good news. It means the fear you feel looking at that list is misplaced. You are not staring at 1,000 things to memorize. You are staring at about 20 things to understand, dressed up 1,000 different ways. So the takeaway, the hundreds of problems you fear collapse into about 20 patterns, and those rest on one way of thinking, which means the real goal is not to memorize more, but to understand less, far more deeply. Before we talk strategy, let us demystify the interview itself, because it is far more predictable than it looks. Almost every coding round follows the exact same arc, and once you know the arc, you are never lost inside it. It starts before you write a single line of code. First, clarify the problem, ask questions, pin down the inputs, the outputs, and the edge cases, then work through a concrete example by hand, so you are certain you understand what is truly being asked. Rushing this step is the most common way even strong coders fail. Interviewers tell story after story of brilliant candidates who wrote perfect code for the wrong problem, simply because they never paused to ask one clarifying question. Then, and only then, you begin with a brute force approach. The simplest thing that works, even if it is slow, and say so out loud, then optimize it, usually by spotting a pattern, and then finally, write the actual code. and you finish strong, test your code on examples, including the tricky edge cases, and then discuss its time and space complexity, how it behaves as the input grows. So the takeaway, every round follows one arc. Clarify, example, brute force, optimize, code, test, complexity, and simply walking that arc calmly and out loud is already half the battle won. Now the single most important idea in this entire course, the pattern mindset. Truly internalize this one thing and everything after it becomes easier. There are only about 20 core patterns worth truly mastering. Not 2,000 memorized solutions, about 20 reusable ideas. That is a number you can genuinely learn in a few months of steady, focused work. And here is why they matter so much. Mastering those 20 patterns unlocks roughly 90% of the interview questions you will ever face. The questions change costume. The story is about trains, or stock prices, or islands on a map. But underneath, it is the same pattern you have already drilled. Patterns like 2 pointers, sliding window, breadth first and depth first search, and dynamic programming appear again and again across every company and every year. Learn to recognize the pattern hiding inside a new problem, and you have already half solved it. This is why two people can look at the same problem and have completely different experiences. The trained eye sees, in seconds, this is a sliding window problem, while the untrained one sees only a wall of unfamiliar words. So the takeaway, master about 20 patterns and most interviews unlock. Because you stop seeing 1,000 unrelated problems and start seeing a few familiar ideas, wearing different clothes. To choose between a good solution and a bad one, you need a way to measure cost, and that measure is big O notation, the language of efficiency. It does not count seconds on a clock. It describes how the work grows as your input grows. Let us climb the ladder from best to worst. At the top, the fastest, O of 1, constant time, where the work never grows no matter how big the input, like looking a value up in a hash map. And O log n, logarithmic time, where each step throws away half of what remains, like binary search. Even a million items take only about 20 steps. These are wonderful to see. Sit with that for a moment. 20 steps to search a million things. That is the almost magical power of an algorithm that halves the problem each time. And it is why big O, not raw speed, is what really decides whether your code survives at scale. In the middle, O of n, linear time, a single pass over the data, like scanning a list once, perfectly reasonable. And O(n) log n, the speed of the good sorting algorithms, and often the very best you can hope for when order matters. A useful habit is to glance at your loops. One loop over the data is usually O of n. A loop inside a loop is usually O of n squared. And cutting the problem in half each step is the telltale sign of O log n. And at the bottom, the danger zone, O of n squared, quadratic time, usually from a loop inside a loop. It is fine for tiny inputs, but at scale it crawls to a halt. And turning an n squared solution into an n log n, one is exactly what optimize so often means in a round. So the takeaway, Big O describes how a solution's cost grows with the size of its input, and learning to name your solution's complexity from O of 1 to O of n squared is how you tell a fast answer from a slow one out loud, the way interviewers want to hear. Patterns or techniques, but every technique is built from a small set of building blocks, the core data structures. These are the containers you store and organize data in, and knowing which one to reach for is half of solving any problem. Let us meet the essential ones. First, the array, data in index cells, sitting side by side in memory, giving you instant lookup by position. It is the humble foundation almost everything else is built upon. And the hash map, which stores key and value pairs and finds any key in roughly constant time. It is the single most useful structure in interviews, the quiet secret behind countless fast solutions. Whenever a problem asks, "Have I seen this before?" or "How many times does this appear?" the hash map is almost always the tool that turns a slow, nested search into a single, fast pass. Next, the linked list, nodes joined in a chain, where inserting and removing an item is cheap, and the stack and queue, which simply control the order things come back out, last in first out for a stack, first in first out for a queue, quietly powering everything from the undo button to task scheduling. And then the two big ones, the tree, data in a branching hierarchy which enables fast search and represents everything from file systems to decisions, and the graph, nodes joined by edges, the structure of networks, maps, and social connections. If you have ever wondered how a map app finds the shortest route, or how a social site suggests friends, the answer is a graph algorithm quietly running underneath. Which is why these two structures unlock some of the most interesting problems in the field. So the takeaway: arrays, hash maps, linked lists, stacks and queues, trees and graphs are the core tools every pattern is built from. Learn what each one is genuinely good at, and choosing the right one becomes second nature. So, how does this course carry you from today all the way to genuinely interview ready? Through 18 modules, built in careful dependency order, so you are never asked to run before you can walk. We begin with the foundations, the basics of problem solving and Big O, modules 1 through 6, the very bedrock we started touching today. Then, we build the core structures, arrays and hashing, linked lists, stacks and queues, trees and graphs, modules 7 through 12, learning each structure and the patterns that live inside it. And finally, we reach the advanced topics, dynamic programming, greedy algorithms, and more, modules 13 through 18. Closing with a capstone that pulls every pattern together into one confident whole. So the takeaway: 18 modules in dependency order, foundations, then core structures, then advanced patterns and a capstone, each one standing firmly on the last, so that even the hardest topics feel natural by the time you arrive at them. Dynamic programming, the topic beginners fear most, becomes almost gentle when you reach it, having already mastered recursion and the pattern mindset in the modules before it, which is the whole reason we refuse to skip ahead. Knowing the path is not enough. How you practice decides whether you actually reach the end of it, and most people practice in a way that quietly wastes their time. Let us compare the two ways honestly. On the left, the trap, grinding random problems. You pick problems at random and solve 500 one-off puzzles, feeling productive with everyone. But because they are disconnected, most are forgotten within a week, and you never build the recognition that actually matters in a room. On the right, the winning way, drilling patterns with spaced repetition. You learn a pattern, solve several problems that use it, and then deliberately revisit it days later, right as you are about to forget. Which is exactly the moment review turns a fragile memory into a permanent one. About 20 patterns, deeply drilled and revisited, beats 1,000 problems grinded once and forgotten. The second approach wins every single time, because interviews reward recognition, not raw volume. There is a well-known trap here. Solving hundreds of problems feels like progress and looks impressive on a profile. But if you cannot recognize the pattern under pressure a month later, that effort has quietly evaporated. Depth beats breadth every time. So the takeaway: practice patterns with spaced repetition, not one-off problem grinding. Work smart, revisit deliberately, and let the patterns sink in until you recognize them the instant you see them. Think of it like learning to read. You do not sound out every letter forever. With repetition, whole words become instant, and in the same way, whole problem types become instant once you have revisited their pattern enough. Finally, what does it actually mean to be interview ready? It is not about having solved the most problems. It rests on 3 clear pillars, and this whole course is built to give you all 3. First, recognize. The moment you read a new problem, you spot which pattern it belongs to, because you have drilled the patterns until recognition is instant and automatic. This is the skill everything else depends on. Second, communicate. You think out loud, clearly and calmly, walking the interviewer through your reasoning, because a right answer arrived at in silence often scores worse than a good attempt explained well. Remember, they are watching how you think, not just what you finally write. Third, code and test. You write clean, correct code, and then you verify it on examples and edge cases without being asked to. That final habit, testing your own code before the interviewer points out the bug, signals real engineering maturity, and it is often the small thing that tips a borderline interview into an offer. So the takeaway, interview ready means three things working together. Recognize the pattern, communicate your thinking, and code cleanly and test it. And by the end of this course, all three will feel like second nature. Let us gather the whole class in one breath so it locks into memory. A coding interview is a proxy for problem solving, not a trivia quiz and not a memory test. Every round follows one arc: clarify, example, brute force, optimize, code, test, and complexity. And about 20 patterns cover roughly 90% of all the questions you will meet. Pickle measures how cost grows with input and a handful of core data structures. Arrays, hash maps, trees, graphs, and more are the tools every pattern is built from. 18 modules, in dependency order, carry you steadily to interview ready. And you get there by practicing patterns with spaced repetition, not by grinding random problems. Next class, Big O notation. In depth, measuring time and space. One idea at a time. Think in patterns. Data structures and algorithms only look intimidating from the outside. A wall of thousands of problems and strange sounding names. Up close, a coding interview is a calm, repeatable process. Clarify the problem. Work an example. Start with a brute force. Optimize it. Write clean code. Test it. And discuss its complexity. And that vast landscape of problems is really just about 20 patterns wearing different costumes. Recognize the pattern, and the solution quietly follows. So please, do not grind 500 problems at random and call it studying. Learn the patterns, understand Big O and your core data structures. Revisit everything with spaced repetition, and practice thinking out loud. Over the next 18 modules, we will build every one of those patterns from the ground up, until interview ready is simply where you live. Next class, we begin with the language of efficiency itself. Big O notation. One idea at a time, let us learn to think in patterns.